All right. So part two of basics of chemistry. Let's talk about writing formulas. This concept is the same regardless whether you have an ionic compound or a molecular compound. The idea is the same. You're going to use symbols to write the particular compound. Let's take, for example, let's look first at water. Water is something that we drink every day. Without water, we'll not be alive today. So, water, the chemical formula for water is H2O. Now, you will notice that we can see the symbol of hydrogen and the symbol of oxygen. And again, remember that you can find the symbols in the periodic table. So we have hydrogen, we have oxygen. Now, this number here, this is called a subscript. This number here, this letter number here, is called a subscript. And this number here tells me how many atoms of hydrogen I have in that molecule. So in water, we have 2 atoms of hydrogen per molecule. We have 1 atom of oxygen. When we only have 1 atom, we don't write a 1 for most of the part. It's like in algebra. In algebra, when you write x, you don't put a 1 in front of it, so it's implied that it's only 1 atom in there. So again, formula for water, H2O. There are 2 atoms of water. Sorry, I made a mistake. I said 2 atoms of water. No. Molecule of water, H2O. It has 2 atoms of hydrogen and 1 atom of oxygen per molecule. Now, let's look at sodium chloride, which is another element. We eat it every day too. We like to use it to season our steaks or chicken. It's salt. Salt is sodium chloride. And again, you have sodium, you have chloride. Now it's called sodium chloride because this is an ionic compound. So when we write the name of the compound, we follow some rules. We change the name of INE in the end of the non-metal to IDE. And again, notice that we write the name of the metal first, followed by the non-metal. And again, it's an ionic compound because it has metal and a non-metal. We can talk about that some other time, but in here, we write the metal first, followed by the non-metal. And again, notice that we are being very specific because if we write don't follow the rules, we can confuse people. Sodium formula, sodium symbol is Na, chlorine is Cl. Now, if I were in here, it is implied that we have 1 atom of sodium and 1 atom of chloride per formula unit of sodium chloride. And the formula unit is almost a molecule, so if you want to call a molecule, by all means, just remember that this is an ionic compound. So in 1 formula unit of sodium chloride, we have 1 atom of sodium, 1 atom of chloride. Again, we don't have the write the ones if there's only 1 atom of each of the elements in that particular compound. We assume it is 1. However, if I put a 2 in here, now I change things because now I am saying, and this is called a coefficient, now I'm saying that I have 2 formula units of sodium chloride. So I have sodium chloride and another sodium chloride. So if I were to visualize this, I will have NaCl and NaCl. So now I have 2 formula units. Now if I were to calculate how many atoms I have of sodium in 2 formula units of sodium chloride, then I will have to multiply this 2 by each of the elements subscript. So if there was because we have a 1 here, so if in 2 formula units of sodium chloride, I have 2 atoms of sodium and 2 atoms of chlorine. Again, notice that you will have to multiply this coefficient by each of the atoms subscript. In this case, it's a 1, and this is a 1. And when we visualize it, since we have 2, we can count 1, 2, 1, 2. So yeah, we're correct. If we do the same with water, if we put a 2 in front of water, now we're saying that we have 2 molecules of water. So that means that I will have to visualize 2 little molecules of water, H2O, H2O. So if I were to calculate how many atoms of hydrogen I have, so I will have 2 plus 2, that's equal 4, and 2 atoms of oxygen. shortcut, multiply 2 by the 2, that gives you a number of hydrogen atoms, multiply 2 by the 1, that is after the oxygen, that will give you 2, so you have 2 atoms of oxygen. And again, the difference is coefficient tells me how many molecules, how many formula units I have of that specific compound. The number here tells me how many atoms I have in the compound, pretty much, of that particular element. Let's look at another example, carbon dioxide, which is a byproduct of combustion. In this case, we have 1 atom of carbon, 1 atom of oxygen. 1 atom of carbon, 2 atoms of oxygen, because we have a 2 here. So, CO2, this is a subscript. And again, this tells me that there's only 1 atom of carbon, because we don't have to write the 1, but it's implied there's 1, so we have 1 atom of carbon and 2 atoms of oxygen. We look at methane. Methane is a hydrocarbon, and it's called hydrocarbon because it's only composed of hydrogen and carbon. So hydrocarbon compounds that are made, organic compounds that are made of carbon and hydrogen only, cannot have anything else. If it has oxygen or nitrogen, that's not a hydrocarbon. Hydrocarbon only contains carbon and hydrogen in it. So methane is the simplest hydrocarbon. It's a gas, and it can serve as a fuel. It's a byproduct in landfill gas. So again, the formula is CH4. And notice again, you write the symbol of each element as it is. So I know that in methane I have 1 atom of carbon and 4 atoms of hydrogen. Anyway, I hope this helped you understand a little bit of chemical nomenclature much better. If you all have any questions, feel free to ask them. I will try to answer them. I think at some point I will have to make a video for ionic compounds, but for now, I hope this video helped you understand a little bit of chemistry. Peace out, and I'll see you in the next video. Bye.